Bum bum ba-dum bum 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 ba-ba-dum bum 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 ba-dum bum. Properties of energy and matter combine to make multiple habitats. Let's look at two scenarios, one on land and one in the water, and see how interaction between energy and matter helps structure where organisms might live. On the surface of the Earth, energy from the sun heats up the ground, which then transfers the heat to the surrounding air. This happens more at the equator because it receives more direct sunlight. The warm air rises, and as it rises it picks up water vapor that is evaporated from the surrounding area. When air rises in the troposphere, it gets colder, and as air cools, it becomes less able to hold water because it becomes more saturated, and the water starts to precipitate out. This precipitation occurs over the equator and leads to the formation of rainforests. Rainforests are plant and animal communities that are adapted to high levels of water. The rising air around the equator draws in air from the northern and southern latitudes. This then pulls the cooled air down and sets up these air cells or currents. When the air comes down, it is dry from having dumped all of its water that it previously had, so it picks up any water in the surrounding areas. This removal of water causes the surrounding areas to be dry. That is why if you look at a globe, most deserts occur at 30 degrees latitude, because that is where the dry air currents come down. Similar conditions can occur based on landscape features like mountains. Large mountain ranges can create this effect on a smaller scale. As clouds are forced to gain in altitude to go over a mountain range, they cool, lowering their saturation point. The air loses its water on the side of the mountain, and as the air reaches the other side, it is dry and picks up any of the available moisture. So on one side, you might find lush greenery, and on the other side, dry, arid conditions. Global differences in temperature, such as the difference between seasons, is due to the angle of sunlight the planet receives. Just like when you have a flashlight and shine it on a wall, the more perpendicular your light is to the surface, the more intense the light. If you think about it, when perpendicular, the energy of the light is concentrated on the smallest amount of surface area. When on an angle, the energy is spread out over more surface area, and so is less intense. Because of the curvature of the planet, as you change latitude, you change your angle to the sun. This is affected by the tilt of the planet. Depending on where we are in our orbit around the sun determines which part of the planet is most perpendicular, which in turn creates seasons. So to sum up, the sun's angle to the earth creates different temperatures in different regions. The radiation for the sun also creates wind currents, which transports water across the globe. Temperature and precipitation alone are able to distinguish between most biomes. These factors are very important in determining location of different plants and animals. Let's look at how energy and matter interact in aquatic biomes. Light is not able to penetrate water as it does air. Even in pure water, the majority of light is lost at depths around 25 meters. This sets up a vertical structure in water for light, with the highest levels of energy at the surface to low or no energy at the bottom. Solar radiation is also the major source for heat for aquatic systems. The diffusion of heat is similar to light and is also structured vertically. The diffusion of heat can create a thermocline, which is a layer in the water where the temperature will drop rapidly as depth increases. Another structured abiotic component are nutrients. Most nutrients come from terrestrial systems, either from weathering of minerals or the decomposition of terrestrial organisms. As such, you can get a horizontal structure to aquatic habitats, where the most nutrients are found along the coasts, with diminishing amounts of nutrients as you get more removed. The interaction between solar radiation and properties of matter, like air and water, create complex habitats that help to create structure to the biological world that overlays them. One way you might see the structure is by looking at the location of biomes. Biomes are stereotypes of biological communities. Examples of biomes might be a desert or a tropical rainforest. A desert in North America, such as the Mojave, might contain an organism such as the cacti, and the African Sahara Desert might contain euphorbs. Although these species look similar, they have different evolutionary past. So they have become adapted in similar ways, but they use different structures for the adaptation. In the Mojave, the cactus has evolved needles from its leaves, whereas the euphorb evolved needles from its stipules. The Mojave and the Sahara are considered the same biome, because even though they may contain different species that are relatively unrelated, the types of species are similar life forms, meaning they have similar types of adaptations and life histories. If you were interested in comparing exact species, you might compare ecotones, which makes distinctions based on species.